Hey guys, Camden's Takes. Today we're doing another solar system video, but this isn't about the planets or the dwarf planets. Today we're talking about the star at the center of our solar system, and that is the Sun. The Sun is a massive glowing ball of plasma called a star, which shaped our planet, solar system, and life itself. The Sun is a G2V type main sequence star, which is also known as a yellow dwarf. We mainly know the Sun because it's the center of our solar system, so all the objects in the solar system orbit around the Sun. The Sun contains 99% of the mass of the entire solar system, so if we combine the planets, moons, asteroids, comets, and more, they'd only make less than 1% of the mass of the solar system. The Sun's diameter is 1,392,000 kilometers. The Sun is located in Orion's arm, 26,000 light years away from the galactic center. It takes 230 million years for it to orbit around the Milky Way galaxy, which means it only has completed 20 galactic orbits ever since it was formed. Here's something that might sound strange today, but in ancient times, the Sun was considered a planet, and it wasn't alone. The Moon was also considered a planet. To ancient astronomers, a planet didn't mean what it means today. The word planet came from the word planentes, which means wanderer. A planet was anything that moved across the sky compared to the background stars. These were known as the 7 classical planets known by ancient astronomers. Earth wasn't on this list because it was thought to be motionless and at the center of the universe. In this geocentric model, the Sun orbits the Earth once a year, while the Moon orbits once a month. This idea worked well enough that it lasted for 140,000 years. But in the 1500s, with later observations from Galileo Galilei, scientists realized something: the Sun was very different. So while the Sun isn't a planet today, it was considered one in ancient times. The Sun is approximately 4.57 billion years old. It formed when a massive cloud of gas and dust called the solar nebula collapsed, possibly from a nearby supernova. At first, the Sun was a protostar, then a violent T-Tauri star, until it stabilized into the calm, steady star we see today. Today, the Sun is alone, but earlier in its life, it might have had companion stars. Most stars don't form alone. They're formed inside crowded stellar nurseries where binary and multiple star systems are common, which leads scientists to believe that it was formed in a small group of stars. Gravitational interactions in these clusters can be chaotic, which can cause stars to be ejected from them, which is probably what the Sun did if it had companion stars. If it had a companion star, it would explain the structure of the Oort cloud. And because the Sun is so big, you can fit over 1.3 million Earths inside it by volume. The Sun is made up of 73% of hydrogen, 25% helium, and the other 2% is heavier elements like carbon and oxygen. Astronomers call heavier elements that are heavier than helium metals. The Sun has 3 main layers: radiative zone, convection zone, and the core. At the center is the core, where it's 27 million degrees Fahrenheit, and that's where the nuclear fusion occurs. Surrounding the core is the radiative zone, where energy moves slowly out as radiation, which is a process that can take over 100,000 years. And the final layer is the convective zone, where hot plasma rises and cooler plasma sinks, which creates the Sun's bubbling surface pattern. Every second, the Sun fuses 6 million tons of hydrogen into helium, which creates the energy that flies through the Sun and even through Earth. The visible surface of the Sun is called the photosphere. Above that is the chromosphere, which glows red during solar eclipses. And surrounding those are the corona, which is millions of degrees Fahrenheit, which is hotter than the surface temperature. The Sun also has a powerful and constantly changing magnetic field around it, which creates sunspots, dark regions on the surface that are cooler and sometimes larger than Earth. Sometimes magnetic energy is released as solar flares or coronal mass ejections, blasting billions of tons of plasma into space. When these hit Earth, they can cause power outages, auroras, and satellite damage. Specifically, on the sun they're called solar flares, but they're just called flares on other stars. Every 11 years, the sun goes through a solar cycle, switching from solar minimum to solar maximum. Every 11 years, the sun's magnetic poles flip, which means one magnetic cycle lasts 22 years. Currently, the sun is in its 25th solar cycle. The sun controls Earth's climate, photosynthesis, and seasons. Without the sun, we would freeze. It takes 8 minutes and 19 seconds for the sun's light to reach Earth. The sun's density is 1.41 g-cm to the power of 3. Its mass is 1.99 times 10 to the power of 30 kilograms. Its radius is 696,000 kilometers. The sun has a differential rotation, which means its equator rotates faster than its poles. In about 5 billion years, the sun will run out of hydrogen and swell up into a red giant, consuming Mercury, Venus, and possibly Earth. And then it will have a larger diameter of 1 billion kilometers. Later, it will shed its outer layers away, forming a beautiful planetary nebula, leaving behind a white dwarf star about the size of the Earth. Over trillions of years, it will burn out into a black dwarf star. Hope you learned something new today. Camden's Takes is signing off. Make sure to like and subscribe.